Continue with chapter 7a, coordinate geometry. Question 15, 16, 17, 18, 19, more or less the same. We have the quadrilateral. So what to do? We have to find all the four sides. Okay, like here you see, we have to find all the four sides and also the diagonal. Then if the four sides are equal, diagonal are equal, then it will be a square. If four sides are equal, diagonal not equal, that will be rhombus. If opposite side equal, diagonal equal, that is rectangle. Opposite side equal but diagonal not equal, that will become a parallelogram. Okay, then if suppose side also not equal, then it will not be a quadrilateral. So since we have to find the length of the side, that means we can apply distance formula. We can name this one as ABC or PQR. Then we find the distance between first and second, second and third, third and fourth, then first and fourth for a side, then first and second for diagonal, first and third for diagonal, second and fourth for diagonal. Then after that we will see those various conditions. Let us name it as ABC. So you can start distance formula. Okay, A and B. Minus 1 minus 1 minus 2 0 whole square. So both minus we have to plus minus 1. So there when we have square minus go away, have 8. Then BC also you take B and C. Remember first with first, second with second. Okay, x with x, that means y with y. So 1 minus from the formula, minus to minus plus, then 0 minus 2. So we have square, minus will go away, 2 into 2 4. Here also we have 8. Then the same way you take the next one, C and D. Compare from the point C and D, you will have minus 1 and minus 3. Here we have double minus, one from formula, one from the question. So minus to minus become plus, so it will be 3 minus 1, 2 again. Then we have the second one, 2 minus 0, which will be 2. Again we get 8. Then next we take A and D. So minus 1 and minus 3. Again here we have double. So minus to minus become plus. Then we have minus 2, 0. So it will be minus 2 whole square. Again we get 8. We get all the four sides. Next we find the diagonal. So we take this one and this one. Minus here become double. So minus 1 minus minus 1. So minus to minus become plus. So 1 plus 1 minus, we have to minus. Then we have minus 2 minus from the formula 2. So it become 4. Okay, so we get 16. We can take out 4. Then next we have another one. We take 1 and 3. So 1 minus minus 3. Minus to minus plus. So 3 plus 1 4. Then another 0 0. So here we see all the four sides are equal, diagonal are equal. It means that the quadrilateral is a square. So the same way you can try for number 2 also. Okay, so that way you take like AB. So we have minus 3 minus 3, both minus become 6. 5 minus 1 become 4. So we square them, we get 52. Then 3 with 0, 1 with 3. So it become 9 minus here 2. 2 into 2, 4. Minus go away because of square. So we plus 13. So you see these two are not equal. Then if you take C and D, 1, 0 minus minus 1, 3 minus 4. So in that way, we get that they are 1 square 1. Both plus, so 7 square 49. So here we see the opposite side also are not equal. Then adjacent side also are not equal. So that means it is not a quadrilateral. Okay, then the given vertices are not quadrilateral. Here you can see we get square root 85, 15, okay? So clearly they are not quadrilateral. Number 3 also you test the same way. You have 4 with 7, so we get minus 3. 5 with 6, we get 1. So we have 10. 7 with 4, 3, right? Then 6 minus 3, 3 again. So here square them, we get 18. Then you have 4 and 1. 4 minus 1 will be 3. 3 minus 2, 1. We square them and plus, so we get 10. Then here you see square root 10, square root 10. Then the same way if take AD, we have root 18, 18. Opposite side are equal. Let's check the diagonal. So if you find out the diagonal in the same way, compare between A and C, B and D, then you see the diagonal are not equal. Opposite side are equal, but diagonal are not equal. It shows that it is a parallelogram. So goes for number 16 also, it will go the same way, okay? You can try yourself. Number 16 will be like 15, 2. Okay, find all the 4 sides along with the diagonal. So if opposite side are equal, diagonal are equal, it will be rectangle. Then for number 16, okay, the diagonal should be equal. Then number 17, find all the 4 sides, opposite side will be equal. Then check the diagonal. If the diagonal are not equal, then it will be a parallelogram. Then number 18 will be similar to 15, 1. Get all the 4 sides with diagonal. Then if all the 4 sides are equal and diagonal also equal, then it will be the vertices of square. That way we will move on to number here also rhombus. And then rhombus, you find all the 4 sides with diagonal. Then as we had done earlier, so all 4 sides are equal, but you'll see diagonal are not equal. That will show that it is a rhombus, okay? Then for this one, we have to prove it a right angle isosceles. So since it is a triangle, we have to find only 3 sides, okay? That means this first one and the second and the third. So we have to show isosceles. That means 2 sides are equal. Then we also have to show right angle. So we have to see the square of 2 sides equal to the next higher side, because it is, we have to show Pythagoras Theorem, okay? Square of hypotenuse equal to sum square of the other 2 sides. That we have to do. So let's do it. So here we can take AB, okay? 3 minus 6 will be 3. 0 minus 4, 4. So 3 square will be, we will have minus 4, 16. Then minus 1 will become square. So because square become plus, we have 17. Then next, we will have between 6 minus minus 1. 3 minus 6 will be 3. 4 minus 0, 4. Square root of 3 will be 9. Square root of 4 will be 16. We get 25. Then since we have to show it is right triangle, we can take the square equal 25. Then 6 minus minus 1 will be 7. 1 minus will come from formula. 4 minus 3 will be 1. So there also we will have 50. Square will be 50. Then next we have AC. 3 with minus minus 1 become 4 square. 0 minus 3, 3 square. So those will be 16 plus 9. Again we have 25. So we get 2 sides 25, 25, which show that it is isosceles triangle. Then if we plus the smaller side, 25 plus 25 equal 50, equal to the higher side. So here we have the Pythagoras theorem. So